Hi, everyone. Welcome and thank you so much for joining us today. It's going to be a really fun discussion. I'm Alex Ganibas with Tecton, and I'm excited to be joined here today with Stefan Klaus, who is the Director of Data Analytics at HomeToGo. And we also have Alex Dean, who is the CEO and co-founder of Snowplow. Uh, so today we're going to be talking about feature freshness. And just to kind of set the stage, I wanted to talk about that challenge for a little bit first. So a lot of you are probably joining because you are working on production, customer facing, real time applications. And so, for your use cases, the most valuable signals are often coming from what users are doing right now, right? What happened most recently is often most important, like a user's browsing activity or transactions. But it's easier said than done getting that info to the model while it's still timely and relevant. And you've got some engineering challenges that you're up against. It's really tricky because, first of all, you have to take that raw live user data and get it into useful features that the model can use. And that's really messy because the data can arrive out of order from multiple sources at different speeds. So, building the infrastructure to handle that gets really complex while also trying to maintain consistency in how things are calculated. You also need super low latency, so reducing the time it takes between when the data becomes available and when it can actually be used for inference. And each step in your architecture is a potential spot that introduces more latency, whether it's data ingestion delays to processing delays. So an event might take hours or days to become observable, and by then, it's not as useful, it's not as timely. So for real-time apps, like you probably run into these problems, and you need the right infrastructure to be able to put the relevant data signals together quickly enough for real-time decisions. So that's why we have Stefan here to walk us through how they solved that using Tecton and Snowplow. So this is just a quick snapshot of what we're going to walk through today. We've got more about HomeToGo and its use case. You'll learn about the technical challenge that Stefan's team struggled through, incorporating live user signals in a real-time ML system. And then finally, a solution walkthrough. So you'll get to see kind of how they put everything together with Snowplow and Tecton, building on their existing architecture that they had in place. So they were able to evolve and expand. And then finally, we'll end with a Q&A. So you can use the chat to drop your questions in as we go, and we'll answer them as we can. If not, we'll follow up afterward. And with that, I'll go ahead and hand it over to Stefan.
All right. Thank you, Alex. Thanks for having us. So yeah, first of all, the obligatory introduction about HomeToGo, in case you guys are not aware of what we're doing and you are in the mood for a getaway, then you are actually at the right place. HomeToGo is the SaaS and AI-enabled marketplace for vacation rentals. And we have one very simple vision, which is on the next slide, that we basically want to make incredible homes easily accessible to everyone. So for our customers, obviously, but at the same time, as we are running the marketplace, we want to be able to provide services for our partners, basically who are providing us with the vacation rentals. I don't want to go too much into detail on the next slide. I think just like interesting, a couple of facts. Last year, we actually celebrated our 10th anniversary. We are publicly listed since 2021. When I say HomeToGo, that actually means the HomeToGo group, because we're not only one company, we have over 800 employees. You can see a couple of the other brands that we are having at the bottom. And we're actually quite prominent all over the globe, with over 30 countries where we have our website and our localized apps. And if you think about our business areas, we basically have the big marketplace, which is the business to customer, where we have over 50 million offers from like over 60,000 partners on the supply side. And of course, we have our software and service solutions, everything around travel. If you have your own vacation rental and you wanna basically like advertise it on our platform, we have channel managers. We have in various countries companies basically with like some more specialized and detailed offerings, like in Italy and in Spain. And yeah, one of the big challenges that we have naturally is like, how do you connect from the marketplace the demand that you're getting with the supply that you have, right? And for the marketplaces, it's traditionally basically the search. So the search is one of our core features and sits in the middle of our marketplace. And of course, this is subject for some smart algorithms, right? And you basically want to do some smart things and want to try to provide the best offering to your customers. And this is one of the areas where we started with building our own ranking model. And if you go to the next slide, which looks funny for now, but it will get better, I promise. So we started like having our own ranking like quite early already for a couple of like since a couple of years. And obviously, I mean, in a very simple state, what you have is you have your data sources, of course, like you have the websites and the apps. You have other data sources for performance. You have this in some data store. Nowadays we are on Snowflake. Initially we were on Redshift. Then you basically you build your pipelines, you transform your data, you build your features, you put these features into the search service, and then the ranking. When we get a request from the user, basically we have the features in there, and then we decide, okay, what's the best thing that we can serve to the customer. The question then is, okay, how do you get the data from the website and the apps actually into your data storage? And this is where we're using Snowplow. And I think we are already quite some old customers. I think we initially started in 2017. I don't know, actually, correct me, Alex, but like I think that was still early back in the days.
Yep.
So why did we decide for Snowplow? Simply because the quality and the functionality of the way we can structure our data and provide them into the warehouse. Snowflake has like a lot of components that makes this like very easy. So if you go to the next slide, you can basically see, obviously you have your tracker. And for the website and for app, you would rather use the JavaScript tracker, but there are like many other trackers for backend and for PHP and like for a lot of different languages. Then you send them to a collector, and they are being put in, like we are on AWS, so in a Kinesis stream, which we call the raw stream of raw events. And then Snowplow is providing with a schema registry. So for every event, you can decide, so what's the format of the data? What are the validations that you want to run? And that's actually key, because very often you have to deal with like non-optimal data or like with faulty data. The validator basically already tells you, well, just give me the good events that basically went through the validation. So if you are really, really, let's say, like strict on how you define your rules, then you can really make sure that only like very good and well-defined data is actually entering your pipeline. The validator is doing one thing. It's basically splitting it into the good events and the bad events. We monitor both on the Elasticsearch Kibana stack, and then the good events are being loaded into Snowflake. And there you basically see this is the first part initially, and like since 2017, a lot of things changed here. I think we started with something called the EMR runners and like a shredding process that was even like happening before you loaded it. That was actually sometimes quite cumbersome. For example, if AWS decided to not give you the spot instances to make the calculation, then luckily, so there was a new way of loading it with the RDB loader, which basically solved that problem to a high extent. And recently, we can directly consume from Snowflake using the Snowpipe. So basically, you just connect to the stream and get the data in a one big fat table. So basically, no shredding up front, and you have all nice in one place. And then we switched to the Snowplow BDP in 2022. And one of the reasons for that was actually that there was a feature on the agenda which was called Snowbridge. And Snowbridge basically is a tool that allows you to read from the good stream and distribute it like to various sources. You can just like take certain events and put it into another stream. You can like send it directly to an API. And because in 2022, we already were Tecton customers, and we said like, oh, that's actually quite handy, because we don't need to build the infrastructure ourselves. We could actually just use Snowbridge, filter for the events we're interested in, sending them directly to Tecton. And this is how this use case was born. And if you go to the next slide, you can see how now Tecton is fitting into the picture. So we use Snowbridge to read from the Kinesis good stream. We use JavaScript to filter the events that basically are interesting for our use case. And it's actually quite nice because you can chain them, and it's actually quite simple to set up. And then in Tecton, they have a native Snowflake integration as well. And with Rift, you can define a batch source for your features, and you can define a stream source, or from Tecton Rift, which basically makes it very nice because you don't need to handle multiple pipelines. You have it in one place, and Tecton is actually checking if the data that is coming from the batch is the same as for the stream. So the only thing you basically need to take care of is that in the definition of the Tecton batch, you have the same filtering applied like in Snowbridge. And from there, you have a history for your batch features. You have the live features coming from the stream. We sent this to the, I think it's called ingest API, right? Stream ingest API on Tecton side. And then Tecton is taking care of the serving. As you know, search is like very relevant. So like latency is key. I think there are studies, if you go beyond 250 milliseconds for like serving a search, people get bored and they basically just like go somewhere else. And that is very nice because when it comes to like high availability services and with low latency, there's actually quite some engineering involved, and we can directly make use that Tecton is providing this to us. And now we get the batch features that we have that are not necessarily connected to the behavioral data. We have the Tecton batch features and the stream, and all of that basically comes together on the search service. And so that is, I would say, roughly the evolution and how these pieces work together. I want to maybe point out one thing. I think when people are talking about personalization, I think the definition of that differs quite a lot, right? I think what for us the most important was not that we basically have the opportunity to, I don't know, use really like PII or identifiable information, but rather, okay, what is about cluster and segmentation? For example, one test that we run is like, is there any value that we see from which marketing entry points our customers are coming, right? Or what are the clicks of the last 7 days? So it's already, let's say, like more on the behavioral side of things, where we have seen we can actually improve the results for the customer and the user engagement.
Really awesome walkthrough. So Stefan, I had a question for you. If we think back to, the very beginning, what kind of features what was the missing gap? Like what kind of features were you hoping to incorporate, but couldn't yet with this existing setup?
So like with this old setup, right? I mean, obviously, you were able to have historical features, but you were not able to, for example, have in-session optimization. So let's assume you have a customer, they do their first search, you see on which offers they are clicking, right? Like where do they spend time? What are the features of the offers that are basically taking their interest? Historically, you would have just like known, let's say, like if your pipeline would run once a day, you would basically just incorporate that information for the next day. If we now in the new setup, we can say, okay, we track what they click, and we track basically where the attention and the intent is going. And when they enter a second search, we immediately basically like can incorporate that. So we don't talk about, let's say, like real time in terms of like a second or whatever, because like that's not necessary. Usually people spend a little bit time before they fire their second search. But these are definitely features we were not able to include in the old setup. And with the new setup, in-session optimization is really a thing.
And how did you know you were ready to evolve to that next step? Like how did you know it was time to incorporate that new information?
No, that's a good question. I mean, I think curiosity. I think if you have, I would say let's say like the literature and the approaches of like what you do with ranking, right, is actually like very well researched. And so at some point you will reach a certain, let's say like a performance plateau in terms of like what you can optimize if you have batch features. And we were simply thinking of like, okay, if is there a value for us if we basically get these near to real time signals into the search? And that's why we started looking into solutions that we can use that doesn't require us to like rebuild the whole infrastructure for ourselves, because we are actually aware that this is quite cumbersome. And it takes actually quite some engineering effort to get this into a production stable state. And all of these components here are basically, they are scaling automatically, right? So basically when you have, for example, we have a weekly seasonal pattern where you say on the Sundays, people love to look for travel on the Sundays way more than like on a Wednesday. So all of these systems are scaling dynamically up and down. So that was our way to not overly spend like too much, let's say, like engineering effort, but still be able to play around with these real-time features.
If you were trying to accomplish the same thing without Tecton, what would that might have looked like?
Oh,
If you just tried
we
to
looked
build this
into
all.
things, right? So like, I mean, so we looked into a couple of solutions. I mean, Feast, right? So like basically Tecton and Feast, I mean, they share a history together. The problem is there is no tool and no framework around that would give you this functionality out of the box. And you would definitely at least need to have one or likely even more engineers who would take care on the whole infrastructure setup. So I wouldn't say that it's not possible, but in terms of like time to action and time to first insight, like using these components, like in the way we're doing it, it was very fast.
And can you walk me through, you're using the Tecton Rift engine. What are some of the benefits you see out of that so far?
One of the things we really liked is it was, and I think we were beta testers at the beginning. I think it was very fresh when we basically jumped on it. I think the one big advantage for us it's Python based, which just like makes it very easy to use. As you know, I mean, there's always the debate of like, hey, are we going with Spark or like going with somewhere else? And Python was like very good for us. The overall configuration work is like very low, right? So you basically really, I think you have like 2 or 3 files that you need to configure. And all of the alignment, all of the point in time correctness, all of the do my stream features match the history, that's basically coming out of the box. And so from that perspective, it was, of course, you need to like know what you are doing, but at the same time, it doesn't require it doesn't have a steep learning curve in order to get started, and that was a huge benefit for us.
So definitely time to deployment was important.
Yes.
Awesome. Well, to get a little more detail on this architecture, I'd actually love to kick it over to other Alex from Snowplow. So Alex, can you take us through a little bit more how that works?
Yeah, definitely, Alex, and yeah, it's great to be here. And Stefan, thanks for the partnership. It's been great working with you guys for this period of time. So I wanted to speak briefly about Snowplow, and I'm very mindful that probably a lot of the viewers of this have a lot of experience around production AI, probably a lot of experience around feature stores, feature engineering, and kind of the wider Tecton suite. So what I want to talk about a little bit more is kind of what is this customer data infrastructure? So what is this technology that kind of feeds the use cases we're talking about here? And for the folk on this webinar that do have some awareness of Snowplow, but maybe have thought of us more as kind of a feed into the warehouse, it's important to understand these kind of very cool real-time use cases that we're powering here with Tecton. So briefly, Snowplow is a customer data infrastructure, and we're designed for builders. So we're designed for data teams, data engineering teams, data science teams, and similar. We're very, very focused on using that set of SDKs we've built to capture the richest understanding of what's going on in your digital estate. So your websites, your mobile apps, your backend processes, and similar. And so this makes a customer data infrastructure is pretty different from an ETL tool or a change data capture tool. Like we're very, very focused on capturing all that digital behavioral signal. And it's no coincidence that we work with HomeToGo. We work with a lot of marketplaces, e-com stores, media, financial services, anyone that has a really big digital footprint and need to make sure they deliver the best digital experiences. So after the event collection, we then move into validation. I won't spend too long on that because Stefan mentioned it, but just to say in these real-time use cases, you need to really make sure the data coming in is as you expect, because these are production use cases. You don't get to kind of fix that later in the warehouse. The data quality tooling then leads into enrichment. And so if you're going to work with this data in real time, it's really important to have it enriched in real time with GeoIP, marketing contexts, all that sort of thing. And then crucially, it's a real-time pipeline under the hood, which is what's allowed these use cases at HomeToGo. And so the real-time stream is available inside your own cloud environment, and it can then be fed, and we'll talk about this in a moment. It can then be fed into Tecton. It works, think of it as kind of a Kafka native architecture. Most important thing to leave you with on this slide is this is all built for data teams. This is infrastructure. This isn't a kind of an export from a package tool. These are dedicated infrastructural pipes to allow builders to create the downstream use cases that they want. Anything from analytics through to personalization, feature scoring, AI, and so forth. So yeah, that's Snowplow at a high level. So I won't spend too long on this slide. On the left-hand side, what you see is kind of the SDKs and then further detail on the Snowplow technology, really underlying that, as well as our fully hosted version. We also run it native inside our customers' own environments, AWS, Azure, and Google Cloud. The thing I did want to stress on this slide is the way that we connect through to Tecton, both through the real-time stream into the streaming pipeline, but also because the Snowplow data is streamed into Snowflake or your data warehouse, the batch processing, batch feature engineering can be treated. And that's a really important point as well, because it's really important when you're feature engineering that your real-time events and the batch history of the events, it's the same format. So you're working with the same data source and the same schemas, whether you're doing the real-time flow or you're doing the historical batch flow. So yeah, that's Snowplow's integration into Tecton. But Alex, yeah, I'll hand back to you to kind of connect the dots a little bit more on the ecosystem.
Yeah. So yeah, a little bit more just to drill more into what Tecton does specifically to solve this. We talked a lot about just now about the challenge of collecting that live user data in the first place, and then Tecton really carries it over the last mile. So we use what's called a declarative framework, where you can declare your features as code, and from there, Tecton actually automatically materializes the infrastructure needed to compute and serve those features in real time. So once you've gotten the data from Snowplow, it's ready to go. You've got those rich, comprehensive behavioral signals, and that's quickly delivered to Tecton. And from there, the code actually serves those both offline and online. And so this is really helpful for that challenge of combining data that's arriving in different states, out of order, at different speeds. Often you might be calculating features from both batch and streaming data sources or request time features. So it really handles that challenge of multiple data velocities. And that's a lot of what Stefan walked through in his architecture, where they're using these different data source types to calculate these features. And so if you want to make sure you're calculating things consistently, you don't want to have to, you just want to have to declare it once with a single definition that's consistent both online and offline and calculated the same each time. So because of the declarative framework, you don't have to build or maintain that complicated stream processing infrastructure that you would normally have to build on your own. It automatically handles distributed state management and out of order processing, and it ensures that same computation logic. And then we take it through the end. I mentioned latency at the beginning. Latency is a huge issue, right? If you have a real-time use case, you want to make sure you're acting on signals as they arrive. So when you get that data from Snowplow, how are you making sure that you're serving that to the model while it's still relevant? So Tecton also provides low latency computation and serving at scale. We have intelligent scaling and caching to serve values at extremely low latencies, even at a really high load, like millions of requests per second. And we do end-to-end pipeline optimization. So where a home-built system might introduce slowdowns at each stage that add to your latency, we actually remove the need for multiple tools for your feature pipelines. We minimize data movement and processing delays and optimize data storage formats. So really, we automatically handle a lot of the very challenges that you're running into when you're worried about fresh features. And that's why, as we walked through HomeToGo's architecture, it made sense for them to be able to get things up and running very quickly with fewer engineering resources, because Tecton handles a lot of the engineering complexity for you. So Stefan, I'm going to hand it back over to you to talk about, I just mentioned engineering overhead as one benefit, but what else did you see as a result?
Yeah, and I want to just like stress that because I think for our case, and I was talking to actually our engineers who like did the whole implementation. Actually, I need to say their names. First of all, everything that you've seen here, I'm just the guy talking. The guys who actually worked on that, it's Audrius and Stefan from my team. So they deserve all the credit. And when we started, both products were basically like in a very early phase. They just like came out, and I think we were like working together with Snowplow and Tecton, like as the first let's say like company like combining these features. I think in the state that you are now, I would say it really takes you around like 1 week of work of let's say like one max like two people to really get this up and running, which is if you just like compare about like how much it would take for the whole infrastructure part to deploy. Yeah, so that is really a speed up. And now when like everything is being set up, it is quite easy to actually add something new to it, right? So like you basically configure a new filter on Snowbridge, you define basically a new feature on Tecton side, and you can get started with the testing on this. I think this is a big benefit for us. Of course, at the moment, what we are looking at is let's say like not where we want to do excessive joining between certain events and information, right? We really just like say we get this type of event, let's say like clicks. It's like very easy aggregatable coming from the batch and from the real time. But for this use case, very fast, very convenient, very stable. So from that perspective, it was really a no-brainer to go basically and try this out. From the business impact, I think at the moment, so we are running, or like we tested 3 different type of these real-time features. For example, one was something like the clicks of the last 7 days. Interestingly, because like this is something that you would expect that like clicks, right? Like, oh, that should be a good signal in order to optimize. Interestingly, we've seen because the spread and let's say like the distribution of the different amount of clicks coming from the users is actually became quite noisy. One thing that we tested afterwards was, for example, okay, give me the marketing entry point. Because very often if you say, okay, somebody's coming rather organically or somebody is coming from paid marketing, there is some intent behind, right? And you can basically like optimize the offers that you are showing based on this intent. And here we actually saw very good results, and we're actually rolling this out now in production. And then of course, like you have the user engagement metrics, and you have like some other metrics that we're looking at, let's say like revenue in the last 7 days or users with bookings in the last 14 days. And we saw positive upticks on all of these metrics on like how we evaluate basically the success on our ranking pipeline adjustments.
Good stuff. Awesome. Well, glad you're already seeing these benefits. We find that a lot of AI teams, for them, fast experimentation, fast time to production is a big one. So awesome. I think we have lots of time for Q&A, and we are getting a ton of questions in the chat. So I'm going to go ahead and start the Q&A portion here and start throwing some questions at you guys. So one we got was from Victor. Could you have done, so I think this one is for Stefan, could you have done the same thing without Kinesis, say using S3 as a poor man's stream, I like that, or DynamoDB, or is it integration only with Kinesis streams?
That's a very good question. I think, first of all, I think the integration is not just like working with Kinesis streams. I think you guys, I mean, you're running on GCP as well. And you basically have various types of ways of leveraging the platform architecture. I think you can build something in this regard, but it would come with like a lot of drawbacks. I mean, like, so basically like selecting Kinesis, just like in terms of scalability and the opportunity, just like using, and basically like a Kafka technique is just like, whenever it comes to, you have like, let's say like certain latency requirements, right? So like all of this is very fast. Like, I'm not sure if you would be able to get the same performance and latency if you just like would need to do the materialization on S3 and then you would basically read it back. I think the whole validator and like splitting events would work in such a convenient way. And I have to admit, I think this is for us, like we never tried it in a different setup. We always went with the stream solution since 2017. I think, Alex, actually, you might say, you might have like more context, but I think the benefits of using a stream architecture here is just like outweighing, let's say, like all the hoops that you would need to jump to if you would go with something else like materialization on a data storage.
Yeah, I couldn't have said it better myself, Stefan. I think that, you know, Snowplow can support other message queues and streaming technologies like Kafka you mentioned, Google Cloud PubSub, but I think fundamentally use cases like these are one of they're one of the best kind of killer apps for making that move from a more like batch S3 based architecture to using streaming technologies. And you know, you can micro batch in S3 and write Lambda functions and stuff, but you're essentially at that point kind of rebuilding a Kinesis or Kafka or Flink style ecosystem yourself. So yeah, always use the primitives that you know your cloud or your vendors provide, I think.
Cool. Really helpful there. Let me actually go back to our architecture slides so we can have this in front of us as we take these questions. Let's see.
It looks like Ziming had a question about materialization stage.
Yes, under materialization stage, how to guarantee the data consistency when it involves joining the data from different sources, in which some sources data updates might not be in time. Yes, really good question. We can get back to you with more detail on that, but that's where the declarative framework for Tecton comes into play. You define the logic once. So often you know, when you've got your ML team, you'll have the data scientists define the code or, you know, come up with the feature first. Then they pass it off to the data engineer. And that's when there's offline, online implementation discrepancies. You'll have to have duplicate error prone pipelines. And so the declarative framework really helps ensure that consistent logic. And we do handle joins really well. So we ensure point in time accuracy. We help with things like backfilling automatically. So we do handle like historical accuracy and out of order data. And then we did have another question. Does Tecton provide distributed setup for reading data from Snowflake, BigQuery, et cetera, using its connectors? And we did answer this in the chat, but just for everybody watching live here, the short answer is yes. So definitely take a look at our documentation for our connectors. We call them batch configurations for a batch source. And we have the link in the chat here where you can learn more.
Could I add in a question? I know we're just working through questions from the group, but I had a question for Stefan, if that's okay, Alex.
Oh yeah.
So yeah, so Stefan, you mentioned the kind of, the importance of like the Python paradigm for feature engineering and how, well supported that is in Tecton. Like, a lot of folk that have been working with clickstream feeding it into warehouses have come from this sort of SQL mindset. Like, how do you kind of bridge from those SQL folk into Python, or is it different people, or how do you kind of explain the kind of feature engineering paradigm and skill set, get them to kind of cross over to the right side of the fence?
Yeah, that's a good question, because like I think actually the interface between these, let's say, like paradigms is like it's actually growing together, right? I think in the recent time we have seen multiple attempts where, for example, right, you can now, I don't know, combine something like DuckDB with something like polars and pandas, right? So like it's getting really close. I think for the transformation, personally, because I'm old, I still like the SQL ways of working. At the same time, I think naturally, if you move more into the ML area of things, I think people want to have a framework like a language where it's just like more convenient to do some testing, right? Like to have your tests defined. I think Python has a great environment for code quality, right? So like you have all these type of linters, and you do not basically have certain type of dialect, so it's quite portable. So I would say whenever it comes to, let's say, like preparation and like transformation, especially, I think we try to do as much as possible as like SQL, and from Tecton Rift, right? Basically, you declare if like you declare from where you want to get which data, but like under the hood, what is like running on Snowflake is like still like an SQL, right? You could just like get it from the source. You basically just like put it into your tables. I think as soon as it comes to building features and connecting them, I think just like Python has the advantages of having a more mature programming language interface. But yeah, very good question. I think the lines are blurry. I think you can see now in DBT, you can natively like put together SQL and Python like in like in single pipelines. But for me, or at least like for my data science and ML team, they are Python first. So we do try to prepare as much as possible in SQL, but then as soon as it comes to the model training and everything, it's going to be Python. Cool. I think the one thing that I wanted to call, what I wanted to say for the Snowplow data, I think for me, one of the biggest advantages that we had when we started moving from the shredded tables into the big fat table, where you basically have every event in one row, is simply the support that you can structure, that you can query semi-structured data so nicely. And you can do this in BigQuery, and you can do this in Snowflake, because all of the splitting and then joining back together was actually creating quite some computational overhead. It was killing the lineage and like all of this type of stuff. And I think with the new technology, where you say, okay, I can simply query my JSON and then extract what I need, it's actually a really nice way of further robustifying the pipeline, because it doesn't matter if there's like a new attribute or like a new key to your JSON. If you don't consume it, great, you can keep it there. And as soon as you want to start using it, you can basically just like adapt your query. I think for data science, that's super important, because very often you don't have an immediate use case for a certain feature right out of the box. But like when you basically start collecting the history, it's like very convenient to just like then backfill and have the data ready.
That's cool.
Awesome. All right, I'll give folks just another minute if they have any other last minute questions. Otherwise, we can go ahead and start wrapping up.
I think there was a new question on the Q&A.
All right, how's streaming feature computation using Tecton compared to doing the same on Apache Flink? Newbie to Tecton, welcome. Thank you for joining. Yeah, really, it's the automation, and we can follow up with more information. But essentially, our declarative framework is really what sets us apart. It gives you consistent logic. It's got optimization, so the low latency serving that I talked through. We handle the things that would normally have gotten super messy and complicated. We find that often AI teams, as they're starting to add more sophisticated features, they're doing more complex things like aggregations, they're handling that data arriving out of order. We make sure things are implemented correctly and consistently, automatically under the hood. I did see this kind of relates to a similar question I saw, but like, for example, for data that arrives late, how do we make sure the feature store is updated properly? How do we handle things that arrive later out of order? And our aggregation engine, which is one of the things that sets Tecton apart, uses updates to partial aggregation. So it'll take the late arriving data into account to update both the online and offline stores when that data arrives. So there's a lot we do under the hood to deal with the many, many problems that you'll run into. But yeah, you can read through our aggregation docs for more detail on that.
Alex, just to add one thing to that, and it's kind of almost, it's a Tecton point, but it's also a sort of an ecosystem point. Is, I think, we've been grappling with these kinds of lambda architectures and the kind of the fast path and the slow path in technology for a long time, and some use cases can be fully solved in a streaming technology like Flink, and some use cases can be fully solved in a warehouse. But it's really clear, and hopefully it's been really clear in this webinar, that like, you got to integrate like the historical data, you got to do the training, you got to integrate like the live feed as well. And so integrating those two things together, the way Tecton does that is, you guys just do so much, you do so much of the hard stuff out of the box.
Exactly. Oh, I love how you put that. Yeah, Snowplow, if you think about it, Snowplow and Tecton are really purpose built for this specific challenge of fresh features, because it's taking care of the challenge of the fresh data and also the challenge of serving it and making sure it's both fast but also consistent, even as you're doing really complex calculations, and combining the different data sources, combining the stuff that's arriving out of order. It's taking care of that for you. So it's eliminating so much of the complexity that you would have had to deal with on your own manually. Cool. Okay, so we are at about time, actually. Thank you all so much for your questions. If we didn't get to it live here, we will follow up with you afterward. And so if you want to try any of this out for yourself, we do have a couple handy QR codes. So you could check out the Tecton interactive demo. It's very quick, just 5 minutes, you're able to start exploring the platform, see how quickly you can actually get up and running with features. And then you can also see Snowplow in action. So you can book a demo, learn more about their customer data infrastructure. And yeah, I think that's about all we've got for you. So thank you all so much for joining. This was a really awesome discussion. You both are phenomenal. And I hope that the folks watching this who are running into these challenges are starting to think about incorporating more live user behavior into their use cases. I'm sure they took away something helpful from this. So thank you both again for sharing more. And that's all we've got for you.
Thanks.
Thank you. Bye-bye.
Bye-bye.
Thanks, everyone.